regarding qualities of air that may affect flight, the density of air decreases as the temperature rises and increases as the temperature falls. So a pilot can expect the air density to decrease as the plane gains altitude. A gain in altitude will usually, though not always, lead to a decrease in air density, no matter what changes there may be in the temperature. And so many pilots would say that air density is more important or pertinent than relative humidity. Humidity can have an effect on aircraft performance, but it is not considered an essential factor. Humidity indeed is just one of three factors, along with pressure and temperature, that affect air density. Air is a gas, which means that it can be compressed or expanded. When air is compressed, a greater amount of air can occupy a fixed volume. Conversely, when pressure on a fixed amount of air is decreased, the air expands and occupies a greater volume. That is, the original column of air at a lower pressure has a lower density. In fact, density is directly proportional to pressure. If the pressure is doubled, the density is doubled. And if the pressure is lowered, so is the density. This statement is true only at a constant temperature. Increasing the temperature of a substance decreases its density. Conversely, decreasing the temperature increases the density. Thus, the density of air varies inversely with temperature. This statement is true only at a constant pressure. In the atmosphere, both temperature and pressure decrease with altitude and have conflicting effects upon density. However, the rapid drop in pressure as altitude is increased usually has the dominant effect. Hence, pilots can expect the density to decrease with altitude. This is, of course, based on the presupposition of perfectly dry air, but in reality, it is never completely dry. The small amount of water vapor suspended in the atmosphere is typically considered negligible under most circumstances, but in certain tropical conditions, it can make a measurable difference. Water vapor is lighter than air. Consequently, moist air is lighter than dry air. Therefore, as the water content of the air increases, the air becomes less dense, increasing density, altitude, and decreasing performance. It is lightest or least dense when, in a given set of conditions, it contains the maximum amount of water vapor. Humidity, also called relative humidity, refers to the amount of water vapor contained in the atmosphere and is expressed as a percentage of the maximum amount of water vapor the air can hold. This amount varies with the temperature. Warm air can hold more water vapor, while colder air can hold less. Perfectly dry air that contains no water vapor has a relative humidity of 0%, while saturated air that cannot hold any more water vapor has a relative humidity of 100%. Humidity alone is usually not considered an essential factor in calculating density, altitude, and aircraft performance. However, it does contribute. The higher the temperature, the greater amount of water vapor that the air can hold. When comparing two separate air masses, the first warm and moist, both qualities making air lighter, and the second cold and dry, both qualities making it heavier, the first must be less dense than the second. And finally, pressure and temperature have a great influence on aircraft performance because of their effect upon density. There is no rule of thumb or a chart used in order to compute the effects of humidity on density altitude. But expect a decrease in overall performance in high humidity conditions.